Dear students, welcome to my new class. In this class, we will discuss about the practical dose calculations, how we can calculate the dose for different individuals. It may be in the form of tablet, it may be in the form of injections, it may be in the form of capsule, it may be in the form of syrup, so it depends upon on the formulation. So step by steps, now I am going to perform different practical dose calculation, that how we can calculate the dose. Before starting calculations, first of all, I would like to define dose. What is dose? So dose can be defined as, dose is the amount of the drug that is given at a time which may be repeated, or the quantity or the amount of drug which is given to an individuals at a time which may be repeated. Posology is the scientific study of dose and its relationships, or simple you can say the science related to the dose. Now what is mode of administration? So mode of administration is actually the complete description of the amount or the quantity of drug, routes of administrations, frequency of administration, and duration of treatment is called mode of administration. So this point is clear. I am going to divide the mode of administration into different categories. So the first one is called the complete description of the amount of drug. It means that how much quantity of drug you are going to administer. The second point is what is the route of administration, how you can administer the dose. The first one is amount, the second one is route of administration, the third one is the frequency of administrations. I mean you are going to administer a drug BD twice a day, TDS 3 times a day, or once a day, or 4 times a day. So it depends upon on the dosage form on the drug, and duration of treatment. So it means mode of administration, it is divided into how much steps. This one is the first step, this is the second, this is the third, and it has been divided into 4 steps. Next, now what is dose expression? How we can express the dose? So dose can be expressed in the term of microgram. So look at here, this is microgram, this is milligram, and this is gram or milliliter. So for examples, now where these standards are used, so it depend upon on the nature of the drug, it depend upon on the nature of the dosage form. Let's suppose I am going to administer injection, so then it can be represented by ml. Let's suppose I am going to administer a tablet oral dosage form, so it can be represented by milligram or grams or microgram, so many and more. So then we will discuss onward. Look at here, this is, for example, let's suppose this is a drug, XX is a drug, so XX milligram mean twice a day or thrice a day. So these are the frequency, and XX milligram per day total in divided dose, for examples once a day, twice a day, or you can say TDS 3 times a day. And then look at here, for example, this is another drug, so it can be represented by milligram per kg twice a day or thrice a day, and this is another drug, it can be represented by milligram per kg per day total in divided dose. And XX is another drug, it can be represented by milligram per kg per hour or per minute. This is another drug, so it can be further calculated, it can be further represented by milligram per square meter of the body surface area. Now this is another drug, so it can be represented, these are the different representation, units per kg or units per kg per hour. So then I will discuss it in my next. Now look at here, this is Plateau Principles, that when the steady state plasma concentrations is achieved, CPS is achieved after 5 to 6 plasma half-life. So as we have already discussed in or previous lecture, especially in zero order and first order kinetic, that how the concentrations, how the concentration of the drug can increase the rate of reaction. So look at here, it's the same. This is the graphical representation. This is the time, and this is multiples. You can say up. This is what T half, and this is plasma concentrations. So here on this sides, I will mention the plasma concentrations on y-axis, and on x-axis you can see this is the time. So now look at the graphical representation, that how the concentration of the drug has decreased with time, and look at this is how this is the maximum and this is the average minimum. Now come toward to the main point. Come toward dose expressions. Now what is dose expressions? How we can express the dose. So first of all, I am going to discuss about the solution. Solutions, as we know that solution is a homogeneous mixture of two or more than two components, so it forms solutions. Let's suppose, for example, percent solution. So percent solutions mean, let's suppose 1% solution mean 1 gram and 1000 ml. It means we are going to dissolve 1 gram and 1000 ml. So it means these are solute, and these are what? These are, you can say, solvent. So 1% solution mean 1 gram and 100 ml. 1 gram and 100 ml. Percent mean 100. Proportions. Proportions, look at here, let's suppose ratio and proportion 1:1000. So what does it mean? 1:1000 mean, let's suppose if we have a drug, so 1 gram, if 1 gram of a drug, it is dissolved in 1000 ml. So this is called what? 1/1000 or 1:1000. So 1 gram and 1000 ml. It mean 1:1000 mean 1 gram and 1000 ml is equal to 1 milligram per ml. So this is clear. ppm, this is another dose expression. ppm is parts per millions. So it means 1 million is equal to 10 lakhs. So one part per millions means 1 part gram or ml, and how much? This is, look at here, this is unit 10, 100,000, 10,000 lakh, 10 lakh. This means 10 lakh grams or ml. So it means that 1 ppm parts per million, it is equal to 10 lakhs gram per ml. Now these are some important terminologies before starting to calculate the different doses. We must know about all these terminologies related to pharmacology. So look at here, what is the importance of dose? Why we are calculating different type of dose? In order to study the effect of drugs depend on the plasma concentration. Desired plasma concentration can be achieved by giving the proper dose with proper frequency. That's why always we are saying that you will have to maintain the concentration of the drug in the body. So look at here. So this is dose, so it can be further divided. One is loading dose and the second one is maintenance dose. So now how we can differentiate between loading dose and, so loading dose can be defined as actually loading dose, this is a single or few quickly repeated doses given in the beginning to attain the target concentrations rapidly. For example, drugs have high volume of distribution vary. So in simple words, loading dose, this is very simple. So this is a single or a few, you can say quickly. This is the repeated dose administration, when we are going to administer a dose repeatedly, and the beginning at the start, how to attain the target concentration rapidly, as we know that the drug having high volume of distributions. VD. Now what is maintenance dose? So maintenance dose, this is the dose. This dose is one that is to be repeated at a specified interval after the attainment of, when you achieve the target. Here we are going to attain the peak plasma concentration, the target, but here in this case this is specified interval after the attainment of target, like steady state plasma concentration. You know that in maintenance dose, whenever we are going to administer a drug, so the rate of administration will be equal to the rate of, in this case the rate of administration will be equal to the rate of elimination, mean the rate of influx will be equal to the rate of efflux, so as to maintain the same by balancing the elimination. So this point is clear, that in maintenance dose, when we are going to okay, so inshallah in my next lecture I will calculate different doses and dosage form, and inshallah I will discuss it in details. Thank you so much.